Right, so what we got here is a particle starts at A with velocity u, acceleration k. Second particle starts at B, distance l away, with initial velocity 2u and deceleration of k. Find the time for them to collide and the condition so that if this occurs before the second particle returns to B. Okay, well, let's just look at the first part. We want them to collide. So the distance traveled by this particle would be s equals ut plus a half a, which is k, and then t squared. What is going on? Squared. Okay. Right, so that's the distance traveled by the first particle. The distance traveled by the second particle is u t plus a half k, whoops, oh my goodness, something's acting up here. And if I put full screen, maybe it'll help. Half k t squared. And if you add those two distances together, you should get L. Okay, let's see. That will be 3 ut, just 3 ut it looks like, s equals ut plus a half at squared, s equals ut plus a half at squared. Yeah. So then the time at which they collide will be L over 3u. Seems straightforward. A little too straightforward, nearly. S equals ut plus a half at squared. S equals ut plus a half at squared. Okay, fine. So the next part was find the time at which the particles collide and the condition if this occurs before the second particle returns to B. So we want the collision to take place, but we want this to happen before the second particle returns to B. So I guess there's a possibility that this could move left and then stop and then head right, and this would just keep accelerating right. They both have the same acceleration, but it's kind of like this one has a bit of a head start because this one has to brake and turn around. So I guess they could meet like somewhere there. So we want to make sure, okay. So we want to make sure the time it takes for this to get back to B will be more than this time here. So the time this will take to get back to B, that'll be S equals, again, but in this case the S will be 0. So that'll be ut plus a half k t squared equals 0. Okay, so that means if we solve this, we'll get t equals 4u over k root. And we need this time to be bigger than L over 3u. Now any specification